Okay. So first of all, let's just talk about a little bit like GRPO.
Yeah.
Okay. That's what it's a type of training. Like SFT is what? Structured fine tuning?
Yes.
DPO, direct process
Policy optimization.
policy optimization. And do we even remember what GRPO stands for? Group.
Group relative policy optimization.
There you go.
I mean, there are different names for it. People are calling it in different ways,
Right?
but the overall meaning is completely similar. Uh, Performing a real reinforcement learning task on different completions,
Right.
different outputs.
Right. And so it's like every year
Hmm.
there's like a better way to do it.
Yeah.
Like originally we needed a lot of data, or the human
Yes.
reinforcement learning. You needed humans, and it was very slow. And then eventually we got it to where we could use less and less data,
Yeah.
right? And then what's very different about GRPO? What stands out?
Uh, so before understanding GRPO, let's just go through supervised
Okay,
and classifications.
okay,
So in machine learning, supervised is a set of tasks where there are few inputs and few outputs. When the model is learning, it takes all the inputs and the outputs as an example and predicts the next token.
okay,
This is how a traditional supervised fine tuning works,
makes sense.
right? So in order to perform the supervised task, we need a lot of data, lot of time and memory,
Hmm.
right? Although we have enough data and enough memory and enough time, we are failing in providing human feedback, human based feedback. You know what I'm saying?
Yeah,
As models are getting bigger and AI is improving a lot, people are more relying upon human based feedback instead of machine generated feedback.
right.
That's where the reinforcement learning came into the picture.
Okay,
uh, so let's understand the reinforcement learning is just of teaching helping the model to learn itself instead of giving human inputs,
sure.
right? As we know, we have different reinforcement learnings, and the GRPO is of one of its kind. Uh, GRPO is um takes huge memory but less data and more time as compared to supervised tuning, fine tuning.
Right.
So one of the key differences is you don't need the outputs. Let's say we are creating a chatbot as of now, and we need for supervised fine tuning we need input and output. What the user is saying, what the model is replying, and we need thousands of data
Yeah.
similarly.
5,000, 10,000,
Yes, you're right.
100,000.
For GRPO, we don't need the the machine output. Let's say you and me are talking about you are the user and I am the assistant, and you have your problem saying your Python code is not working. For supervised fine tuning, we need your input and my output in order to train the machine. For GRPO, we just need your input to solve the problem. You have a problem with the Python code, and the GRPO doesn't need my answer, it generates the answer itself.
So that's so interesting. So GRPO is basically what Deepseek R1 used, and one of the significant things that's different about GRPO is that you write reward functions
Yeah.
in code,
Yes.
in your Python code, for instance.
Yes.
So that's why we can take an input of the question, just the input prompt is
Yes.
what Tej is talking about here, and then we don't need the answer
Yes.
because the answer is going to be completely generated by your reward functions and the LLM, and that's what's going to train it. So that's
Yep.
what's interesting about GRPO.
Yes.
And so there's examples of taking like a non-thinking LLM, and you
Mhm.
start rewarding it for putting thinking tags inside. And so that's one way to start adding thinking to a non-thinking model. Or in our case, we are tackling cognitive behavioral therapy type inputs and responses.
Yes.
Yeah. So you've been working hard. We've been reading some really good stuff from the catch up.
Yeah.
By the way, I bought the pro subscription.
Oh, thanks.
We
Yeah,
need
it would be
we
really
need to start
helpful.
asking them some questions
All
because
right. Yeah.
we now have access. I recommend the catch up. It's I found them on Medium at first, and then I think they went to Substack. But like when you're doing this stuff, it's all about signal to noise, right? You
Yeah.
only have so much time in your day as a data scientist, and you need to start with notebooks that have a chance to work.
Yeah.
But then there's still a lot of work, and we're going to take you through Tej's journey of what he learned on GRPO. But even starting with the catch up, which a lot of their work on this particular notebook 143, we recommend, it is based on the Unsloth notebooks. So you can also go to Unsloth's GitHub. And Unsloth is just a really great way to use less memory. It's a library, and there's a particular tech stack that you use. And maybe you can talk a little bit about the exact tech stack that we went with
Yeah.
to get GRPO working.
Yeah.
But then there's also, we're going to talk about the format of the data.
Yes.
We're going to talk about how did you learn that? Because like Gemini wasn't giving it to you, O3 from OpenAI couldn't solve it. I think you did amazingly, old-fashioned way.
Yeah.
Go read the fucking manual, RTFM.
Well, it is what it is.
Yeah.
GRP is kind of new, and I mean, I don't know all the models which are available. ChatGPT, Gemini, Claude doesn't have much information. Even developers didn't perform uh, much more tasks on GRPO. So the only way to learn and understand the concept is through documentations.
And then on top of that, we're trying to tackle a very complicated subject matter, which is called cognitive behavioral therapy of a thought record. And what that means in psychology is the psychologist will try to get the user to think through their negative thoughts and say, wait, and they'll get them to come to their own conclusion that, wait a minute, maybe I'm a little too harsh on myself. What if I reframe that? Do I feel better? So that's what this particular exercise is. So there's some papers on
Yeah.
CBT on top of all this GRPO that we're trying to get going. So what do we have today? Just curious, is this notebook just a general GRPO notebook that's working, or is it within the context of CBT data?
So it is working with the context of CBT data.
Okay.
Firstly, we have to work with the datasets. So datasets are the core.
Okay.
Second is working with the unsloth.
Yeah.
And datasets, unsloth configuration, and prompting the dataset is very important.
Okay.
And last most important thing is reward functions.
Okay.
Right? So in order to perform the GRPO, these four are the essential things.
Okay.
Right? Fine. Our data, let me show you. So, okay, so this is kind of, okay, this is how our data looks like in the run pod. But when you open in VS Code, we can easily able to see the JSON files.
Sure. But
Right.
like, what's the next reply? The assistant?
Okay.
That's right.
Yeah.
Okay. Now, so let's talk about this. So, is this the final data that worked? Because you just woke up this morning and had a breakthrough,
Yeah.
and you're saying you don't need to put user assistant. You need to put
Just user.
just user.
Yes.
Okay. Because we don't need the assistant's answer.
Yeah.
We thought we did in the data.
For supervised fine tuning tasks, we need the assistant data, but for GRPO, we don't need it.
Well, let's talk about SFT for a moment. Someone in a Discord group told you, hey, do you have a warm-up adapter?
Yeah.
In other words, they wanted you to do SFT to warm your model up before you put it in GRPO.
Yes.
But do you still think you need that?
Definitely.
You do?
Yep.
So if you're going to warm it up, you need this type of data.
Yes, definitely.
Okay. So you're going to warm it up with this type of data. And the warm up period is, you see the item 1, the assistant,
Yeah.
you put the reasoning and answer tags in your data itself
Yes.
to warm it up. And you did how many iterations of SFT? And then what'd you do? Put it in a LoRa?
Yes. I've used your LoRa.
Okay. So you warm this up with the LoRa. You have your base model.
Yeah.
You do SFT and you put a LoRa on top of this.
Yeah.
Did you squish the model back together as one model, or do you keep LoRa stacks going?
Okay. I will tell my,
Okay.
the complete timeline of what I performed.
Okay.
Uh, I used the same data to train the supervised fine tuning.
Mhm.
And I also used the LoRa configurations. Right after the complete SFT training, I used the adapters as the warm-up models in the GRPO.
So when you load up GRPO, you're loading up base model plus adapter
Base model, LoRa adapters, and the warm-up models.
and the warm up models.
Yes.
So all of them going.
All, yeah.
Oh, that's kind of complicated. That's cool.
It is, but so these the supervised the reason I'm used the SFT is just to build a foundation for the GRPO, to let go how the model should perform while doing the inference. Right. Like I said, I utilized the base model. I've used Quen 14 billion model,
Right.
and I just froze all the adapters using LoRa,
Okay.
and only 0.49% of model have been used for the entire training, and it worked well.
Did it?
Yes.
I mean, but I got to pause you right there. So I keep trying Quen 2.514b instruct.
Yeah.
And when I give it a good system prompt to reply with a reasoning and an answer tag, it does well.
Yes, you're right.
So did you ever figure out why you really? I mean, if your results are that warming it up made it better, I'm going to believe you. But did you ever figure out why your model doesn't, like, we would interact with it and it didn't look like it needed any warming up. It looked like it would follow a reasoning and an answer tag 90% of the time. But what's your experience?
We should give a thumbs up to the Quen models, the Quen family, to just follow the system prompt and give effective answers. Unlike other models, Llama is not that good as the Quen generating.
Right.
On the other side, I would say, as I've worked on model building, right, I can guarantee that just you used a base model and given a system prompt. On the other side, I've performed the complete fine tuning of building the foundation, giving a right system prompt, and especially the context of our information. As we are working on the CBT therapist, there are different examples in our data explaining the different scenarios. But while you are using Quen base model and giving system prompt, you don't give the core information. You just give the information about the CBT and ask you to respond in a certain format. Fine tuning is something different. We give data for training. We use warm up model for SFT to give a foundation,
Right.
and we also performed GRPO to learn itself. And I would guarantee, I would definitely say that the base model as you performed is way better. I mean, my model, which is fine tuned, is way better than the base model which you have performed.
Do you mean full fine tuned, or do you mean LoRa?
LoRa.
Okay.
Full fine tune
I
is
thought
kind of
you said
complex.
full fine tuned for
No,
a second.
it's
I'm just
quite.
calling you on that. If you said that.
We can try a full fine tuning. We have Ketchup's video
Yeah.
notebook on full fine tuning using Onslaught.
Yeah, but I don't know if we need that. So I mean, I just want to stay in. I don't want to stay in LoRa or Q LoRa.
Yeah.
Is it quantized LoRa or LoRa?
LoRa, just
LoRa.
LoRa. Yeah.
Okay. We're doing in 16-bit float
yes.
precision.
Onslaught itself has the quantization.
Does
No
it?
need
Okay.
of adding specific bits and bytes, just similar to transformers.
Okay. Okay.
And this Unsloth has a different mechanism of flash attention,
Mm.
so that just squeezes the model adapters, the memory, and perform it for the huge tasks.
Yeah.
That is why we can give a thumbs up to Unsloth.
Yeah.
Way
Yeah.
better.
So really good luck with Onslaught. And you're just to kind of recap, you're basically saying really good luck with the Quinn models over Llama models.
Yeah.
Like
Yes.
we tried with Llama 3.2, nowhere near Quinn 2.5.
Yeah.
Okay. Maybe we'll go for Gemma models sometime.
Yes.
But because I'm kind of impressed with the, I've been impressed with the Google models before the hype happened with their success with Gemini. I kept testing the Google models, and there was something about them that I thought was performing well. So I think they're going to do well as well. I'm calling that.
Yeah, I haven't gone much about it, but there is a concept called QAT, which performed by the Google. QAT is performed. It's a quantization at training, I think so. So
It's like QA but better because it has the letter T on it.
yeah, something like that. I don't know, but they said they do quantization they do pre-training, quantization at training, and training,
Okay.
and then quantization.
Right.
That's a different
My head's
scale
spinning.
of-
All I know is that they put something kind of good on it, right?
yeah.
Okay, so
something.
we were going to expect the Gemma to be good. So Quinn.
Correct.
Okay, so we went with Quinn. Okay, so to back up, so we've established the best practice is take a good base model,
Yeah.
and we're suggesting just start with Quinn 2.5.
Yes.
Take a good learning source. Well, I'm suggesting the ketchup.
Ketchup is really good.
Yeah. And I just want to remind you, Unsloth sites themselves is really good. So you got all that goodness, right?
Yeah.
And then you read the documentation, you reached out in Discord, you realized you needed a warm up fine tuning
Yeah.
that's got the user assistant, and then the answer has the tags that
Yeah.
you're had. These are like XML tags
Yes.
basically.
Yes.
This isn't JSON output. These are just XML style
XML.
tags,
Yes.
which I find work really well. And because the tags are easier sometimes for LLM rather than like all the brackets and commas that can get messed up,
as you can see.
right? So so we have all that, right? And so where do you store your LoRa adapter? Okay, so we're on. Wait, is this is Colab?
Run pod.
Oh, this is RunPod, right? So we tried on Colab, but we ran out of credits, and we found it almost impossible to pay them more credits.
Yes.
When you choose a certain path
Yeah.
on Google Colab, it doesn't just let you upgrade
Yeah.
and add money, which is annoying. So now we're on RunPod.
Yeah.
Can we just see the dashboard of our pods real quick and just show what we picked? Yeah. So RunPod. Okay. So which one we're on pod for demo?
Pod for demo. Yeah.
Okay. So you get to see all your pods. You get to see like if your GPU is being utilized and if they're on or off. But I want you to notice we used an L4.
Yeah.
Okay. And I think I bumped up the no, you didn't bump up your disk space. I always bump up my disk space because I'm afraid of running out. Did you run out?
As you can see, I just put it to 30 GB, but
Oh.
still, we are
I
out of
always
memory.
go for like 50, 60. You're
I
so
would have tried it.
you're so conservative. Okay,
Yeah.
yeah. So bump up your disk space a little bit. Choose an L4. L4s are just highly available.
Yeah.
And they are so when you close a run pod down, it's only like 25 cents a day
Yes.
to just have your whole environment stored over there.
Yeah.
Right.
Yeah.
Whereas Collab, and in run pod, don't forget you want to store your stuff in the workspace folder.
Yeah.
If you made some other folders that you spun up temporarily, those will be gone. But if you put it in your workspace folder,
It will be easy. Yes.
yeah. And then in Collab, we kept having to store our work and connect to
Hugging Face.
to where?
Hugging Face.
Yeah, like either you push stuff up to Hugging Face to store your stuff, or you temporarily store some content on the G drive.
Yeah.
I didn't find it as convenient. It just like this. We come back to our work, we push play again,
Yeah.
and then you click the connect button, and then off you go. You can get your notebook back, and you're in.
Yes.
Okay. So, all right. So that was the fine tuning data. Where did you store your LoRa off? Did you store it up in Hugging Face, or did you
Yeah, I
store it?
stored them in Hugging Face as well as we also have in workspace folder.
Oh, in the workspace folder
Yeah.
too, huh?
Yes.
Okay. So you do. Are those checkpoints during your SFT or your GRPO?
GRPO.
Okay. All right. So let's get back in your notebook, and I think we got the base level concept there.
Yeah. Yes.
So where are we at?
So, like I said, this is the training, right? Uh, uh, During my experiments, I tried Unslot 1.5, which is also really good as compared to Llama.
Mm-hmm.
The Llama 3.28 billion. I cannot say it is good, but it can perform for the supervised fine tuning task.
Mm-hmm.
And these are the weights I've used in order to perform LoRa.
Okay.
This is a Q value, key value, and query value. This is a big concept of LoRa. Quite complex. Even it is very hard for me to understand.
But up at the top of your notebook, do we still have to use? Help me with the bits and bytes and all, like go all the way up.
Yeah. So, yeah, like I said, we need to install Unsloth as well as the bits and bytes, but we don't need to mention the bits and bytes configuration.
Why
Bits
not?
and bytes engine. Unsloth has its own mechanism to perform. It takes the 16-bit instead of 13-bit.
Okay. But you still have to install bits and bytes.
Yes. Yes.
It's just something in the background, some libraries it needs.
Yes.
Okay, but basically it's unslot. Okay, gotcha. And then what else do we see here? There's a patch. We got that from the notebook. That's
Yeah.
straight from the notebook. Don't. Okay, that's good. That's just standard stuff. Okay. So anything else? What about in your LoRa configuration? You kind of skipped over that. Row 7, cell 7. Anything in this tokenizer?
Yeah. So Unsloth, we have to load in. We have to keep a few things as true in order to activate the quantization or deactivate the quantization. If we are doing a full fine tuning, we have to keep it false, and we have to do one more configuration. Ketchup has that notebook. I haven't gone through it yet, and we also have the ability to do perform fast inference in the training itself. So we can configure in the engine, Unsloth engine, before doing the fast inference. And most important thing is GPU memory utilization.
Yeah. So you just play around with that
Yeah.
if you're running out.
Yes.
And with the advantage of turning it up a little more is can your batch size get bigger, or like if you use more memory, is it helpful?
It depends on our model. As we are using 14 billion model, right?
Yeah.
Putting up to max likely to help and perform better.
Okay. So and then the fast inference, the VLLM is just a beast. It's very good at caching
Yeah.
the
I
KV,
mean,
and so basically instead of needing two GPUs to run all this,
a single GPU.
you can do it all in one.
Yes.
Excellent.
Yeah, and of course we need a Hugging Face token. Okay, here's what I suggest people to work with the adapters. The moment you got training and you got the adapters, save them to Hugging Face, and it is really easy to pull from the Hugging Face using Hugging Face token instead of working with the local folders in the run pod or whatever.
Yeah, because you were working with the local folders for a while, and why didn't those work out? Just more complicated code, or just something magic Hugging Face does when you're pulling it down?
Right. So sometimes, let's say I've trained on my computer and using your computer to do the inference. When I shared the local files to your computer, maybe it crashes a little bit.
Hmm.
If a file has 167 megabytes, while I'm transferring, it only comes with 160 megabytes instead of the full
Wow.
file size.
Huh.
Yes. So saving it in the Hugging Face would really help us.
Something, some kind of
Yes,
some kind of secure mechanism there.
exactly.
Okay, gotcha. So, all right, interesting.
Yeah. So these are the different tests I performed. But yeah, you know, here also
Well,
I've
hold on. I think we skipped just a little bit. Let's go look at it. You know? No,
okay, fine. Yeah.
this isn't very relevant.
Yeah.
What do you think?
So for training, we don't need to use this system prompt.
Oh, we don't use it.
Yeah.
Oh,
For
so at first we thought we used the system prompt
yeah,
that had an effect on GRPO.
yeah, but
It doesn't.
no, no.
Okay, let's skip it.
We need a simple prompt. Let me show you. So like a second most important thing, I would say a very important task is reward functions.
Okay, so now we're getting to the heart of GRPO.
Yeah.
And then how do you, how do you do a policy? So all of these reward functions are called during training time. Each reward function has an equal weight. In other words, if you have 3 reward functions, it'll add up all the rewards and essentially divide
Give
by
a-
3 for the overall reward.
Yes.
But also we're going to keep track. We're able to keep track of each learning function if it's improving. So what you wanted to do is you want to see that you want to see that curve.
Yeah, for visualizations.
And for a while we were just seeing zeros.
Back then we used to see zeros.
Yeah,
But
so-
now the model performed better.
Right. I'm just saying if you see zeros, that
The
does
model-
mean it. That does
yes.
mean it's not learning.
Yes, 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 yes.
As much as you think you've done all the wishful thinking and you think you've done everything right,
Yeah.
this thing is touchy.
Yes.
Right?
Yes.
So let's take it through some let's see this emotional validation.
Yeah.
Because everybody wants that in their relationship, right?
Yeah. Yeah. I mean, as we are talking about the machine to be performed as a human, these are the main things we have to notice, how the system is model is replying.
Okay. So basically, we're going the chat like take the first one, completions. That must be is it all 8 completions?
8
that
completions.
so when GRP runs, it creates 8 completions.
Yes.
They all come into here at once. Oh yeah, for completion and completions.
Yes.
And I just thought it just handed one at a time.
No. No. So, yeah, I've gone through the same you are the whatever you asked. I've gone through the same, like how Unsloth can optimize the 8 completions in one go and give the output. It is a big technical thing to explain, and
Yep.
it's quite hard. But
But
yeah,
basically, know that completions is a variable that is a list of 8 attempts
Yes.
of the LLM to answer, and you're
Yes.
going to. So let me understand this. So you're going to reward you. I see you going through the list there, right, for completion and completions,
yeah,
and you're basically looking for if those words, those keywords, are in there. So if I have like, let's just keep it so I can do 5. Let's say I've got 5 completions that come in,
yeah,
and this one did good, this one did not, bad, bad, bad. Are you averaging the
Yes.
reward for all these?
yes,
You are.
yeah,
So it's not just like this one was good. You're giving it one reward for all of
yes,
these.
yes,
Oh, interesting.
yeah.
So what is the what's the min max score that comes out of this?
uh, as we see, if it is like minimum 1, minimum like maximum 1.0 and minimum is 0.5. If it ranks between 0.3, 1, 0.4, it just do the standard deviation of all and get a standard deviation of a certain value. Let's just imagine it's 0.4. If any out of 8 completions has more than 0.4, that would be coming as an output.
Can we do the math real quick on this? Like,
Yes.
I mean, let me just get a basic calculator out. So you're telling me,
Yeah, here you go.
okay, so
Right.
so you're telling me if let's move it out of the way a little bit so we can see the algorithm. So your final algorithm is score is
Let me show you.
like if we have
One.
Yeah. Okay.
One model, one output have 1.0,
Mm-hmm.
1.3, 0.4, sorry, 0.4. Let's just say take 5, 0.5
Yeah, but real
and
quick,
0.3.
just like let's say we had five matches out of
Yeah,
four matches out of 8.
yes.
So what's point?
So this is the standard deviation.
Okay,
Sorry.
so is it doing standard deviation or is it just simple math? Is it just saying point five times 4
It's
and we get 2, and you're just saying the minimum out of 1 or 2, and so it's going to go back down to 1.
exactly,
Yeah.
exactly.
Okay. So basically, you're saying if you get like 2 matches out of the 8, you're going to get your max score.
Yeah,
That's what this is doing.
yes,
And if otherwise 0. So the only 3 values that could come out of this function would be 0.
first, yeah,
0.5 times 1 match is 0.5. And compared to 1, it would give you 0.5. And then if you get 2 matches or more, it's going to give a 1. So it's either 1.5 or 0.
0, yes, something like
You like that chunkiness of just like that, that, that?
that. It depends. Uh, how well the model is taking those keywords in its output.
Mm-hmm.
So if it gives like all these things, it just gives a good ranking for it. Or it fails to do any of these, according to the situation, according to the completion, it gives the minimum output. But the whole point is it compares the mean and gives and ranks the output.
Okay.
If a mean is
I just feel like this is going to be a really easy reward function for it to
yes,
hit. I mean,
yes,
in your training, did it basically just go
yeah,
peg to 1 really fast?
yes,
Because I feel like, okay, so it got that part. Okay, so this reward function is easy.
yeah,
So it's okay to have like really softball easy ones.
yes,
Okay, you learned something
yeah, yeah,
like a kid.
yeah,
Here you
giving
go. Here, here.
giving a treat, giving a reward.
All right, let's look at the next one. Um,
So following the techniques. So this is really important
mhm.
of how the model is following its prompt. As CBT has a proper, clear, a table format of how to perform it.
It's like 7 steps.
Yeah,
What you
exactly,
need to
7
do.
steps.
Okay.
So this is what it is.
Okay. So if we go all the way to the bottom to your math formula, it's sorry, in this one,
Yeah,
it's 0.25.
yeah,
So you've got to get 4 of these right to get your max score. And then you're adding 1.
yeah.
So this can score a 2.
Yes, between 1 point some change to 2. We have the reward functions down below. Yeah, well, let's just go through it and
But
we can
you
understand
don't have
clearly.
anything zeroing out here. You don't have like else 0. So this one's always going to score 1, 1 and
Yeah.
some change all the way up to 2.
Yes.
So why did you do that for this one?
So, unlike the keywords, it is just perform. It is not including the keywords. It's just following the pattern, right? So while just following the pattern, it just rates from 0.25 to 1 instead of getting a 0 because it definitely follows the pattern. You know what I'm saying?
I see. This could go as low as oh, I see. This could go as low as 0, right?
Yeah.
No, I mean as low as 1. So in other words, like the min of 0.25 times 0 technique counts. Boom, you get 0 for that half. Add 1. So in other words, it's always going to score 1. Might score 1 or higher. Are you doing that because you want to weight this particular function higher?
Not like that, but we have to balance the reward functions. So we are performing 3 reward functions here. We have to balance. We have to give 0 for one function, and we have to give a minimum for one function, and for following the structure, we have to give 0 as well. It is quite complex. It's better to go through the documentation of understanding the reward functions and adjusting to our specific task.
Right. But at first we weren't giving these mathematical answers. We would score from 0 to
Yeah.
0.5
Yes.
as the only output.
Yes. Yes.
Very very few rewards.
Yeah.
You couldn't even score 1. And so this is different. So even though the documentation is complex, what is the purpose? Like, let's look at the last word of a function, but
This is the core.
oh, an easy one, right?
Easy.
Okay. So let's see. So you have a format you want. You want these tags.
Yeah.
And at first we were doing simple, like, are the tags in there?
Yes.
And this is way more complicated. And what would you say the meaning of this whole function is? What is it trying to reward?
First, it ensures the reasoning tags. And if you have reasoning tags and the answer tags, you get a point,
Mm-hmm.
right? And inside the reasoning tags, do you get the validation keywords? If you get the validation keywords, you get the points.
Mm-hmm.
And if you perform the techniques inside the rewards and answers, you get a point.
Mm-hmm.
Like I said, so it is not only performing the reasoning and answering, it is also taking place of how the answer should be performed, should takes place in the reasoning and the answer tags.
So your other two functions that wanted those words inside it, I'm surprised to see them repeated in this function as well, right? But did you try with and without, and you found this just worked better?
Let's take this example. Let's say uh, um, we have an exam,
Mhm.
and we keep a book in front of us and try to understand everything. So the more we understand, the better rewards we get.
Right?
And the third function is writing the exam.
Okay.
The first two functions are like how well we are understanding, how well we are understanding the concepts, how well we are using the keywords. And the third function is writing the exam. How well we have understood those things, how well we are performing what we have understood in the exam is what the third function is. And we are giving the rewards while writing the exam as well.
I see. So do you think we're always going to see something as complicated as this third function that has to put it all together?
Yes.
Oh, interesting. We weren't doing that at first. That's a big, like, I mean, we literally were doing very simple, like, one thing was just checking tags.
Yes.
The other thing was just checking for a couple of keywords.
Yeah.
That's all we had.
Yeah. So the reason to do the warm up, building the foundation with SFT is just because this.
Good. So
Right.
give it a chance
Yeah.
to start to earn these rewards.
Yeah.
Otherwise, it just whiffs.
It gives the tags, but it doesn't perform what kind of data it should keep in the tags.
Interesting.
That's how.
Okay.
And yeah, here you go. The most important thing. No, not this. This is one kind of reward function which have failed.
Oh,
After
let's look at that for a second. Right. So this is an old reward function,
Yes.
right? And
Yes.
this is us just searching for reasoning and answer tags.
yes,
You can see how different this looks, right?
yeah.
Okay. Let's move on.
And yeah. So this is a basic template to perform reward functions in the GRPO. In order to perform write the reward functions, we have to also consider this following template, so that the specific GRPO trainer, the engine, can understand these reward functions.
Okay.
Right. So this is the main prompting the dataset. All right. So as you can go, I just loaded the JSON file, and I loaded the base model here. So the reason to use base model is applying the chat template. So chat template is also a different concept.
Right.
We have to understand.
Yeah. So chat template is putting all those secret little tags in.
Yes.
The original language model had like strange, like, start assistant, end sentence, end of everything, just weird little
Yeah.
angle bracket tags all over the place. And so where do we apply the chat template exactly?
Right here. So we have a specific. So here's the mistake I've done.
Okay.
I'm using a transformers chat template.
Yeah.
All for a while, but the TRL library itself has a particular chat template that is compatible for the GRPO. This is what I've understood while going through the documentations.
Okay, so help me understand this. So TRL, I thought TRL is the transformers,
Yes,
and then
but
so you used to import something besides go back up.
yeah.
you used to import something besides apply chat template.
Uh,
What were we?
we have a tokenizer dot from pre-trained apply chat template library
Hmm.
back then with the transformers. But the TRL library itself themselves have a specific apply chat template that
Hmm.
can just eliminate the errors inside the model if you
Okay.
found any, right?
Okay. So we load our JSON data. We've got our model. Do you have a very small model there? It's not the. It's not the.
For tokenizing and converting the data, we can use any
Oh,
model.
okay. Oh, okay. Just for tokenizing. Okay.
Yes,
So examples, dialogue. Okay.
right.
So this is where you're just pulling out. Is this where you're removing the assistant yet?
Yes. So we pulled out our assistant here, only prompt, and here in the role dialog we get the user,
Mm-hmm.
right? And for the prompt tag we get all the questions instead of the complete output,
Mm-hmm.
right? And we are converting it to the Hugging Face. So I would also recommend to go through dataset from list library in order to understand how the GRPO works with the
Okay.
datasets. This
That
is
makes
very
sense.
important.
That makes sense.
And like I said, the apply chat template library.
Mm-hmm.
You don't need a complex code in order to put the chat template. When we use the apply chat template, we just put the example. Example is the data, and the tokenizer.
Right.
Tokenizer is the model,
That's right. You
and
use
it
a
just
small model.
converts. Yes,
Mm-hmm.
that's it. And here is the sample. Before that, we have with the JSON tags, and after applying the chat template, we have uh, uh, you know the chat template tags.
Yeah.
The user can easily understand.
Yeah. Yeah. And I usually I like to go to the Alama model site.
Hmm.
They've got some really good examples of like what those tags look like.
Yeah.
But right, I guess you can just see it right here. This is nice.
Yes.
Hmm.
And yeah,
But hang on, we still have we have system prompt. We have
the question
just the question, and the data set does not contain
answers.
the answers. So
Ah.
that's significant. That's that you woke up today,
Yeah.
you had your tea,
Yes.
and you're like, wait a minute, I don't need the. It's so weird to say, I don't need the answers in my data set.
Yeah.
That's a weird thing to say.
Exactly. Exactly. Yeah. All this time, I am working with the data that has user input and model output,
Hmm.
and I'm figuring out how why the reward functions are not performing and why the model is not training.
Right.
Although we have the data, although we have the outputs, it just learns. But that is not the case for the GRPO. It just need the questions like inputs, and the outputs will be given by the model itself and ranks themselves with the reward functions and build the model.
Well, it's so weird, but if I think about it, if we're going to train this whole model on reward functions,
Yeah.
I guess that makes sense.
Yes. Yes. Yeah. That is true.
It just feels like a trust fall.
Yeah.
Like a trust fall is where you just like you shut your eyes and
Yeah.
there's somebody's going to catch you.
Yes. Yes. That is what it is doing.
Yeah, it's just this feels like you really got to trust. You really have to trust your algorithm that's giving the rewards.
Exactly.
Huh.
Exactly. Yeah.
That's kind of scary.
It is, but yeah, whatever we see on the inference, just scares off.
All right, so
Well,
so we got that. So that's a good sample. You can
Yeah.
you can see your sample. Okay, great. So we got all our data ready.
yeah.
All right, I'm with you.
All right. So this is one more your practice which I performed. So it is not that important for us.
Okay.
I'll just skip. I'll just go
Mhm.
to bottom to the hyperparameters and the training arguments.
Yeah.
As you can see, I've increased the learning rate from 1E6 to 2E6 because to perform fast inference, as we are using 14 billion model, and we have a good GPU. We have 24 gigs of GPU and we are using LoRa.
Mhm.
So increasing the learning rate wouldn't impact that much.
Hmm. But hold on, I think most people notebook starts at like E negative 6, E negative 5.
Yes, yes.
But sorry, help me with my basic math. 2E negative 6. Isn't that a smaller learning rate?
No, we can most of the time.
Help me with mathematical notation. E negative 6. So is that's a
So
bigger
there are
number or a
the
smaller number?
a smaller number.
A smaller number, right?
Yeah, the minimum is 1e6, 1e5, 1e negative 6, 1e negative 5, 1e negative 8,
Mm-hmm.
and if we go to its maximum, we have 5e negative 6.
Oh, okay.
Yeah.
Gotcha. Oh, right. Oh, right. A lot of people doing 1e
Yes, exactly.
negative 4 or 5, right?
4 or 5. Yeah.
And so that's actually smaller.
Yes.
Okay, sorry, yeah, but the more when you go 2e3, 2e negative 4, negative 5, that
It
number's
just
shrinking though, right?
yeah. It
But
just
we're at
helps the
2.
model to learn faster.
Yeah, no, I didn't see that we'd put the 2 in front of it. But scientifically, if we went 2e negative 9, that's that's even smaller than what you have there, right?
Something like that. Yes.
Sorry, I'm just trying to remember my math. I just don't remember my yeah. So that's okay. Got it.
And a recommendation. So Ketchup has a PDF, a documentation
Hmm.
of explaining everything, every hyperparameter
Yeah,
that we perform in model
yeah.
building.
You spent like 3 days
Yes.
hold up reading
Yes.
that.
Yeah.
You're like, hold on, I'm gonna understand every hyperparameter. But at a big swatch, if you'd put 1e negative 4,
Mm-hmm.
that would be a slower learning rate.
Yes.
And since you went up to 2
Yeah.
with a lot of zeros in front of it, that's fine. But it's still a faster learning rate than what we started our original notebook.
Exactly.
And you're okay with this learning rate.
Yes. We can also push to 5e6, 5e negative 6, but I don't know how it performs.
You might miss your gradients. You might, I mean, that you're gonna just swing your gradients all over the place.
Yeah.
All right. And so let me just ask you, I'm going to stay on this learning rate. So if we put that down to 1e negative 4
Mm-hmm.
and you ran the same amount of steps in all of this,
Yeah.
and then does it take like literally when we spin up the run pod and it says how many hours, is it literally going to take like maybe twice as long? Does it affect the time or does it affect the quality?
Time.
It affects the time.
Time. Yes.
So if you turn that learning rate really slowly,
Mm-hmm.
you could literally number hours that your training is going to
So
run is going to start boosting up.
in general, the more time we give, the better the model understands,
Mm-hmm.
right? But we have a GPU which is 24 gigs of VRAM,
Mm-hmm.
and we are using the 14 billion model,
Mm-hmm.
right? 14 million is quite big
Yeah.
as compared to what we are working with, the 3 billion model parameters, 8 billion,
Mm-hmm.
right? And adjusting this learning rate can help the model to perform faster,
Okay.
and it doesn't crash. The main thing is it doesn't crash.
Right.
I,
Okay. Well, we're going to find out when it comes to inference, but I mean, this is part of the fun. But I mean, but you know, our training tests are taking 8 hours, 30 hours. Like, I mean, these things can take a long time.
Yes, you're right.
So now, right now, we're using Unsloth, and I think at the time we started all this, I think Unsloth can't do multiple GPUs. We can't like spin up a bigger run pod cluster.
Yes.
But I saw some stuff in the Unsloth Discord that looked like they either solved that or they're solving it. I'm not sure which, but I would pay more than 43 cents an hour
Mm-hmm.
to decrease my time
Yeah.
gladly.
Yeah.
I'd have a cluster of 10. I'd pay $4.30 an hour if it could get done faster.
Yes, we can do that, but it need a specific configuration. We have to go through the documentations again to understand how we can utilize two GPUs to make the work faster.
Yeah,
That's a big
I
process.
mentioned that next. So
Yes.
okay. So anyway, so we've got remind me BF16 versus floating point 16.
Um,
Do we remember what the difference is? I don't want to tank too much, but at a high level.
yes. I've gone through lately. I've gone through it lately, but I forgot. So in general, Unsloth uses 16-bit
Mm-hmm.
instead of 32-bit as Transformer uses.
Mm-hmm.
Um, you know, keeping BF16 can optimize the performance faster, as the floating point 16, is like a traditional way of building training the model, So BF16 is a new way that has a different configuration as compared to the floating point 16.
Okay.
Right.
Yeah.
So
And
Unsloth can take the task of BF16 where the transformer cannot do it.
right. And it's been around a while. Everybody's liking it. And then with
Yes.
the new Spark from NVIDIA and their other machines coming out, I think they're about to introduce like
Int 4.
no, isn't it floating?
No, they are working on int 4 instead of int 16 and 32 bits.
Okay.
They're working on int 4.
Okay. But it's just interesting to watch, like, how NVIDIA can just shape like probably the new number of bits you're going to be natively training in.
Yeah.
That's kind of cool. All right. So per device batch size, gradient accumulation. Okay. Any other hyperparameters you want to go over?
Batch size.
Mhm.
So batch size and the accumulation gradient accumulation steps are very important while training. So it impacts model, it impacts time, and it impacts performance as well, right? So whenever we are training a model, if it is like 3 billion model or 8 billion, we can just put batch size to 4, batch size to 8 if possible. If we have a 24 gigs of RAM, that is really helpful.
Yeah.
On the other side, adjusting the gradient accumulation steps is also very important.
Right.
As you can see, I've put batch size of 1 and accumulation steps as 2. So it goes, let me show you. As you can see here, the total batch size would go in 1 batch size and 2 accumulation steps is like 2. So the concept is very interesting. So if you put batch size 4 and gradient accumulations 2, it goes like 1 4 into 2. It's like batch size goes to 8.
Okay.
And I've put here batch size 1 and accumulation steps 2, and my batch size is 2. Right? Let's just go through a formal way of how the neural network architecture works. The forward propagation and backward propagation. Right? So when the model runs with the forward propagation, it just updates the weights and give a training loss for after it's
You've written this on a napkin twice for me. I think we
check.
need to do a whole show on it.
Yes, exactly.
Okay. All right.
Exactly. Yeah. Okay. In very short notice, the batch size can help in updating the weights faster, and these gradient accumulation steps help even to perform these batch size way better instead of only giving a batch size. It goes in such a way. Batch size with the gradient accumulation steps can help the model to minimize the GPU optimization and learn faster.
I'm gonna need a whole course on it. I mean,
Yeah, exactly.
we both have our data science degrees.
Yeah.
I don't know. You only learn so much from that, and then you come in here and have to read the documentation again. I'm sorry, I'm not at the. I didn't really retain much from my degree at the like pure math level. I just want to know what I could practically get out of it. So
Yeah.
basically, from a practical, if you go back up from a practical standpoint, obviously, play around with those and watch how many hours it's going to take for your whole training.
Yeah.
See if that fits your lifestyle. Okay,
Yes, exactly.
because like I like them somewhere in the range of like I either need to go to sleep at night and then see it the next morning,
Yeah.
or I'm willing to wait a whole day. And I mean, I'm just human. That's how I think. It's like I can either wait, like, those are my time sinks that I want. And then you basically played with those until we could get like an overnight run.
Yeah. Yeah.
Okay, I'm happy.
When you go through the ketchup, he gonna help you to learn this a lot better.
Yeah, yeah, absolutely.
And
I mean, I was talking from a practical standpoint. We talk, and I'm just like, look, can it run overnight? Do we go to sleep, and then we wake up, and the next day is like Christmas or a holiday or just like your birthday?
yeah.
Okay, that's all we're saying.
So I mean, what I understood is, as a data scientist, we need to learn these parameters more so
Yeah.
that we can save the time we can understand the model better,
Hmm.
and we can perform different tasks,
Yeah.
on our level. When you go to production, we have also work on time, we also work on performance, and we also
Hmm.
work on impact, right?
Yeah.
So
So if you get these out of whack too much, you probably need to go look at your hyperparameters
yes,
again.
yes, yes, and you can be so confident that how you can train the model.
Yeah, and unfortunately, these training processes take so long. It's not like you can do an easy, grid search.
Hmm.
It's not like you could have like, I'm going to try every value, right? You just don't have enough time. So it's better. What you're saying is, actually go learn what they mean. So your few times, if these take 30 hours to go learn, right?
Yeah, yeah, yes,
It's going to be months before you could go through a hyperparameter grid and have just covered the whole field. You can't do that. You have to make good decisions.
yes.
So and then the other thing is max steps and save steps versus your epic. Help me understand that again. All I know from a practical standpoint is if I do max steps 10,
Mm-hmm.
it's a lot shorter and doesn't
Yeah,
do as much training,
yes,
and I don't get to see my reward functions doing increasing.
yeah,
Save steps is kind of important to me. If I think anything's going to crash or need to go back to it, it uses disk space to like
exactly,
chunk off like here's where we were.
exactly.
Now when I've done MLX, I do save steps every 5 times because a year ago MLX would just crash every 5 minutes. So so maybe these save steps aren't as important, but it's also nice to be able to just maybe go into that folder, go try out the LoRa after 10 steps
Yeah,
and be like, okay, this is where we started, and then after 100 steps, and then you can just go see for yourself. You can pull these folders back out,
back out. Yes,
and
yes.
then you can go do some inference with it, and just as a person, just see how you're doing. But help me understand an epic versus steps,
Um,
because an epic to me is you go through all the data one time.
yes,
Is that still do I still have that right?
exactly.
Okay, and how much data do we have?
Um, 473 examples, I guess.
400, like less than
73.
less.
Um,
You're talking.
Scenarios. It goes in scenarios. So uh, it is difficult to explain. So as every while working with the model, we use thousands of data, right?
Mhm.
But for GRPO, we don't need that much of data. We just need
So
small
didn't we
examples.
generate five? I made a generator, a synthetic generator.
Yeah.
I think I generated what 500 conversations.
Yes.
And then did you stick with the idea that those conversations would be spliced up into little pieces of the
Yes. In a
conversation
list format.
and then get bigger and bigger?
Yes.
So in other words, we can take one conversation that's got like 5 interactions between the therapist and the user.
Yeah.
And so the first piece of data we give is just the first interaction, like one sentence from the user, one sentence from the assistant. And then we go back and we do that same piece of data within further in the conversation, further and further and further.
Likewise, like we have 473 examples.
Okay, so we have about 500 scenarios that turn into about 2,500 pieces of data, maybe
So yes.
something like that.
Yes.
Okay, and so an epic would be going through all 2,500 inputs from the user.
Yeah.
Okay, now if an epic is 1 and steps are 100, tell me what that, what does that mean?
Um.
Steps.
His this is something like some interesting, right? Here, as you can see, we have 473 examples,
Mm-hmm.
and we put epoch 1,
Mm-hmm.
right? If we adjust the training steps, our epochs will also change.
Mm-hmm.
You know what I'm saying?
No, I
So
don't know what you're saying yet.
uh,
That's why I'm asking.
yeah. All right. So in general, I've only trained for with 100 steps, but in order to perform well and in order to test the model in the production, we have to upscale it to 300.
No, I got a question. So if you did 100 steps and we have 473
Yes.
examples,
Yes.
does it make it through 100 of those examples? Or does it do 473 examples 100 times?
So it just divided into batches as we put the batch size into two, right?
Mm-hmm.
So these 473 examples are divided into a couple of batches.
Into pairs?
Yeah, batches.
Like, is a batch like, in other words, if I have 473 examples and batch size is 2,
Yeah.
is it taking user sentence 1 and user sentence 2?
Yeah, these batches will be sent into the steps.
Okay.
So these batches will be trained in hundreds of steps, 100 steps. And if we keep a number of epochs one, right? So if we can train able to train the whole model in 100 steps, the model itself adjusts the epoch one. Or if it is like something big, and let's say if we have trained with the 4 batches in 100 steps, the model automatically adjusts the epochs
Yeah,
to
you know what?
3.
I am totally forgetting all of my training from last year. No, seriously, this baffles me. We're gonna have a whole show just on this
Yes.
because, look, to me, as a layman data scientist, I'm just asking myself, did it make it through all my examples? And let's just move on. All I know from a practical standpoint is, 100 steps
Yeah.
seems to have an effect by the time it's trained. You know,
Yes.
for 8 to 30 hours.
Yeah.
This
Exactly.
this is a practical standpoint, and all I know is I get to see the steps accumulate down below with the training loss and the reward functions.
Yeah.
I don't know if you can close that Jupyter window, but I can't see all our data. So anyway, so these are 100 steps, right?
Yeah. Yeah.
So all I know is I have to put enough steps in here so I see the reward function getting smarter.
Yes.
But let's take a look at this data real quick. You know, I'm I'm mildly skeptical because it jumps around a lot. Like by the time we get to step 15, and I know that's normal, but like it starts pretty high.
Mm-hmm.
Time to get to step 15, we're up at 0.7 of the overall reward function, and we just kind of wander. I see step 60 looks really good. So what is this data mean in terms of the way it's progressing?
So one thing we have to remember in working with GRPO is, as the training steps go forward, we need to see a slight increase in the reward functions, so that we can easily understand the model is learning better. And in general fine tuning process, we look into the training loss, right? And we understand if the training loss is getting smaller, the model is learning better. But here we have to depend on the reward functions. As you can see, in the first reward function, it calculated 3.38 score. And it just improved a lot in step 15, 3.52. And as going forward in step 50, it learned it to its maximum, 3.9. Right? And just adjusting itself of going to 3.6 again. And it is at a point like it just understood everything, but it's just giving a strong foundation to make the code make the model intact to perform better.
Yeah, but I'm skeptical. I mean, I'm used to seeing a chart of like training versus validation, and they converge. And like, are you telling me after step 50, do you think we overtrained? Because it goes down.
Not like that, but it is at a certain point, as you can see. Where is it? Okay, it is at a certain point. It is not uh, too minimum, as you can see. But it just adjusts its parameters, and sometimes learn better and give maximum, and sometimes it just adjusts itself. But we are looking into the reward functions of by calculating 3 individual reward functions, right? So there is a slight difference in each reward functions, as you can see. In step 90, the format learned a lot better, right? And for the emotional validation, it learned not that great, but at a certain point, right? I, I mean, it all give a proper result in inference testing,
Okay.
right?
I mean,
And we also see how the training loss is performed, right? It's 5.6, which is as per my understanding, which is good.
okay,
But
and let's talk about KL.
KL divergence, yes.
Yeah, so that's basically in a nutshell. If that gets really high, Then it forgot. It catastrophically forgot
Yeah, we just
its original training.
divert from what it is learning.
Okay, so is that a good value? It looks low to me, but numbers are relative.
Yeah,
Is that good?
I can say it is good, but we cannot just look into the numbers. We can just perform the task at different time intervals and
Okay,
see how it
okay,
goes.
okay.
So that is how. And for the VLLM, I mean for the inference,
Mm-hmm.
this is the proper code. And we should also have to talk about VLLM,
Mm-hmm.
right? One time,
Mm-hmm.
uh, how it saves time, how it is too fast.
Yeah. Well, so
Uh,
far, just thumbs up is a good
yes,
way to say it.
yes, yes.
Okay.
Right. So here, as I've said, instead of loading from the local directory, we can just load it from Hugging Face.
Okay.
That is way easier.
Okay. And
And
then where to me this adapter path looks like it's loading local model.
yes, I have to change it though.
Oh, okay. We
Yeah,
haven't changed the Hugging
yeah.
Face. Okay.
So we are using LoRa here, right? We're just giving a proper optimization of, in the LoRa engine. We are loading the base model, and we are giving the. I'm. It's too complex to understand these parallel set and the remote code. It takes time to understand. Fine. We are enabling the LoRa, the adapters.
How about from a practical standpoint? Now that we've done the training on the GRPO, which used a warm up adapter,
Yeah.
when we go to inference, can we drop the warm up adapter and we just go with the train LoRa?
Uh, you mean the SFT?
Yeah, the SFT was kind of a warm up
Yeah.
LoRa,
Yes.
right? That
Yeah.
you needed to shoehorn into the training part.
Yeah.
But now that we're over here on the inference part,
Yes. We don't need to use.
we don't need the warm up anymore,
No.
right?
No. No.
It was warmed up to get trained, and now that resulting LoRa is being applied to base model.
Yes.
Just need that.
Yes. That's it.
Okay, that's from a practical standpoint. Okay, let's move on then.
And as VLLM have these sampling parameters,
Uh-huh.
we have to adjust. So these are the most important things we need to take care of: the temperature, and the top P, and the max tokens.
Yeah, it's
Right?
pretty hot temperature, but okay.
Yeah, yeah. I mean, it
Yeah.
just gives
Yeah.
good results.
Okay.
Right?
Well, can we see it?
I don't know. I have some problem with the Hugging Face right now.
Oh, so we'll come back to another.
And we are out of memory.
What do you mean? What do you mean?
Let me try. Let me try. All right. So
Let's give it a go.
just get to it. This is the problem we have with the run port.
Yeah.
Every time we restart the kernel, we have to install all the libraries again.
Yeah. So over in the My Pods area, you can see. I mean, basically collab the same, right? You load up one thing that you're doing, and something goes wrong, and you try to load the model back up. You got to do a lot of resetting.
Yes.
Maybe we're doing something wrong. Don't know.
Yeah, we can put these libraries in a disk file, and we can use the disk file instead of running it all over again. But that's a different process. And so we can change the system prompt here, as we are discussing, right? For here we can change of system prompt however we want, so that, and we can test the model how it goes.
So at inference time, system prompt matters again a lot.
System prompt matters a lot.
Okay. So if you go to the run pod dashboard, just curious how much memory we are at while it's loading up. So
It
right
didn't
now,
start the model again.
yeah, okay. GPU's not doing anything.
Yeah.
I don't think you're going to be out of memory now that it looks like you've reset
Yes.
to me.
Let's see.
Okay. All right, where are we at? And so it's just it's installing our whole environment.
Yes.
Okay. Does it have to download the whole every time we want to do run inference and we're starting from a fresh kernel start? Are we downloading the whole 14 billion Quinn model again and again?
It is a one-time task. If
One
we
time,
just, yes,
it's stored it off, took it away.
once we download the model, every time we restart the kernel, it just downloads the shards
Okay,
instead of the whole model.
just the shards. All right,
Yes.
that's fine.
All right. Yes, it's going through. Fine. Let me try.
Valid credentials. Is it hmm,
Okay.
is it trying to use our Hugging Face credentials?
Yeah. In order to load the model, we have to specify. We have to take it. We will take it from uh, Hugging Face. Still same issue. Okay. I think we have to fix it. With,
Okay, we'll come back.
yeah.
And I know we're showing our Hugging Face token on thing.
Yeah.
I don't know in all the horrible ways we could be hacked, but you know what? How about you people be nice? That's probably the most naive thing I could say, but just just be cool. Trying to show you information.
Yeah. Yes.
Don't be a dick.
I don't know
We'll have to go shut those.
I don't know how much we are learning, but this the fine tuning process is too complex, and I can definitely say that scientists or developers are finding ways to improve this process so that every developer, not like a regular data scientist, can perform this task in
Yeah,
the real
but
world.
but even as data scientists, we got our training, we got our degrees.
Yeah. Yes.
I try not to sleep in class. I don't think I slept in class.
I did it.
Yeah, all right, maybe. But I mean, we're human, right?
Yeah.
But a lot of it's just practical,
Yeah.
right?
Yeah.
Can you get a notebook that you can reliably run and do it again, right? Do you understand the concepts? And then, I mean, look at this simple thing of just us trying to run inference. We've ran inference a dozen times over this last 2 weeks,
Yes.
no problems at all. And then we need to come in and run inference, and I mean, so just practically just getting everything aligned so that it's like smooth day to day. And I know there's a lot of fancy systems, maybe like Data Robot and all these other huge platforms that help you do this, but I think it's good to learn it at this level.
Yeah. So here, I don't see this is a big problem because we can fix it in minutes.
Yeah,
The main challenge is when the model isn't performing well,
right,
or when the training crashes. That's where the real challenge is.
right.
These are the regular problems that we can solve.
Yeah.
Before that, I worked with transformers for inference.
Hmm.
I haven't gone through the VLLM yet. That moment, and you remember you suggested me to try the VLLM.
Right.
The moment I tried it, and it saved my work, hours of work.
Yeah.
Right. I feel like we need study, more and more study as we going forward.
Hmm.
Instead of just performing what we know.
Hmm.
If we have more study and more understanding, it makes our work really easy.
Right.
Yeah, that is what I understood
Yeah.
in the entire process.
Yeah. So we'll come back when we got inference, because like you really don't know how your training went till you
Yes,
till you go to
exactly.
use it.
Yeah.
It's a bunch of theoretical numbers.
Yes,
So we're good.
and I can. I'm 100% sure that it works well.
I'm not. I don't know if I call myself a realist or a skeptic, but all right, we're gonna see. All right, we're gonna sign off, and
All right.
we'll see you on the next time.